Okay, in this video we are going to see how to use the calculator to conduct a chi test for independence. So, if we are faced with this exercise where we are asked whether the number of salad per meal is independent from the position of the person in the university, meaning whether they are students, professors, administration, and we are asking to conduct a chi-square test for independence. So the null hypothesis would be the number of salad meals per week is independent from the person's position in the university. And the alternative hypothesis would be no, there is actually a dependence between the position of the person and the number of salad meals that they take per week. How do we test this with a calculator? So for your calculators, my calculator on the computer is a bit different, so I took a few pictures. You would go in the statistic menu, you would click on test here, then you would choose chi, and instead of choosing goodness of fit, this time you are going to choose two ways. You are then going to arrive on this, where you are going to need to input what you have in a matrix. So how do we do this? Here, as you can see, you have the observed matrix, which is the only one that you are supposed to fill. So let's click on matrix, and all of them are empty. You might have some old ones. On my calculator it resets every time, so you can delete any matrix, okay, F1, or you can delete all of them, F1 as well, okay, so that we make sure that we start with something which is fresh. So here, as you can see, I have 1, 2, 3 lines and 4 columns. So I'm going to say, okay, what are the dimensions? I'm going to click on OK, and it's going to ask me for the dimensions. The first one is the number of lines, so 3, enter, and 4. And when I click, I'm going to be faced with a table which looks exactly like this. If I made a mistake, and if there was one too many row or not enough columns, I can always click on row, for instance. I can delete one. Look, I can delete one. I can insert one. And same thing, exit. I can do the same thing for columns. I can delete one or add one. So the important thing is that at the end I have 4 columns and 3 lines, just like I have here. I'm then going to input my values, so 45, everything is now in it, exit, so I have my matrix, which is a 3 line per 4 columns, exit again. Observed is in A, the expected is going to be calculated automatically, so I can click now on execute, it's just that easy, calculate, and I can see that the chi statistic is 15 point something and that the p-value is 0.02. So meaning that if I assume that the number of salad per meal is independent from the rank of the person in the university, there is only for me a 2% chance to get this kind of observed data. So 2% chance is lower than 5%, the 5% level of significance. So I can say no, I'm going to reject the null hypothesis, and I'm going to assume that there is a dependence between the number of salad meal per week and the position in the university. So that's the whole thing. As you can see, the degree of freedom are calculated automatically as well. How do you calculate it if you wanted to know? It's the number of column minus 1 times the number of row minus 1. I had 4 columns, minus 1 is 3, multiplied by, I had 3 rows, minus 1 is 2, so 3 times 2. This is where the 6 come from. You don't have to know that. Just for you to know, if you exit here and you go back to the matrices, so if you go here to the matrices, you can see the B1. You don't need to know it as well. I'm just explaining what it is. And you can see it. This is the expected one. So your values here have been compared to the expected values if there was an independence. You still have your matrix A. You can delete them. Make sure that you delete them when you start a new exercise. So look, delete them all, F1. On another similar example, if I want to see if the quality of the meal is independent from the meal, whether it's breakfast, lunch, and dinner, what the difference that you can see here is that I have the total. So I don't want to impute to put the totals into the matrices. So basically, I'm just going to use a matrix 3 by 3. Let me just show it to you. So again, menu, stat, test, chi. My one is slightly different because I don't have a goodness of fit, so you go directly to the good one. Matrices, dimension error, okay, exit. So I want to click on this, and it's telling me there is an error of dimension because I don't have the matrix yet. If I click on it, I want a 3 by 3 here, so that's easy, no confusion between rows and columns. And then I'm just going to put 101. There we go. Exit, exit, and the expected is going to be calculated by itself. Calculated. If I assume that the quality of the meal is independent of which meal it is, I would have only a 2.6% chance to get such result, observed result. So that's very unlikely, and I'm going to reject the null hypothesis and suppose that there is indeed a dependence between the quality of the meal and the meal it is. As you can see, again, the degree of freedom is 4 because it's 3 minus 1 multiplied by 3 minus 1, 2 times 2, 4. Again, you don't have to know that. And yet again, you can see the expected matrices here. If you click on it, that would be the expected numbers if indeed there was independence. And our numbers were far too different to suppose that there was independence.